Hello, Professor Dav. My name is Yuangfa Burkum. Today we are going to explore a technology that sounds like science fiction, but is rapidly becoming science facts, homomorphic encryption, the key to a private digital future. It's groundbreaking approach to cryptography that promises to redefine our relationship with data privacy in the cloud era. We will uncover what it is, why it's a game changer for business, the challenges it faces, and realistic path for its adoption. Let's start with the fundamental problem. For the case, if we want to analyze or process sensitive data in the cloud, say a confidential financial forecast or a private health record, we have to first decrypt it on the servers. This creates a moments of extreme vulnerabilities, a eureka moments of for hackers. Homomorphic encryption solves this. According to Christian, it allows a third party like crowd server to perform calculation directly on your encrypted data. They do the work, but they never see the raw data, and they send you back an encrypted result that only you can decrypt. Think of it like a seal lockbox. With homomorphic encryption, you can give instruction to check the box, count the item inside, or even perform complex operations, all without ever breaking the seal. The crowd does the work blindly, and privacy is preserved from start to finish. So why does this matter right now? The implications are truly transformative. First, it unlocks the full potential of crowd security. Imagine the pharmaceuticals company running complex drug discovery simulation on encrypted genomic data in the public cloud. The cloud provider power the computation, but has zero access to the sensitive underlying data. This is true zero trust model for data in use. Second, according to Signoras, it enable privacy preserving cooperation. For instance, multiple competing banks could cooperatively train a super fraud detection algorithm by pooling their encrypted transaction data. The AI model learned from the combined dataset, but no bank ever sees another bank's proprietary information. Similarly, hospitals across the globe could cooperate on medical research using real patient data without violating privacy law like HIPAA or GDPR. Homomorphic encryption turned data privacy from barrier to cooperation into its very foundation. Now, homomorphic encryption or HE is not a magic bullet. It comes with significant challenges that we must be honest about. A primary hurdle is performance. Computation on encrypted data are inherently slow and more resource intensive than no pen tech, sometimes by a factor of a hundred or a thousand. There also major implementation complexity. This is cut-edge cryptography and expertise required is still rare. However, the field is advancing rapidly. The mitigation strategy is clear. One, we must be selective, applying key only use case where data sensitives justify the computational cost. Two, according to IBM, we can leverage the growing suite of cloud-based He2 from giants like Microsoft and IBM, with abstract away some of the complexity. Three, and we should use hybrid approach, apply heat to the most sensitive part of data workflow, not entire pipeline. Giving these challenges a Big Bang rollout is impossible. Success lies in a phase strategies roadmap. In phase 1, over the next 6 to 12 months, the goal is discovery and education. We need to form a task force to identify the perfect pilot project, a high value, sensitive data problem. Concurrently, we must build internal literacy through workshop. Phase 2, in the next 1 to 2 years, is about running a control pilot. We take that chosen we use case and use crowd-based homomorphic encryption library to prove its work and delivers value in content environment. Finally, phase 3, looking 3 or more years out, is about strategy integration. Here, we take the lesson from our pilot and begin to standardize homomorphic encryption, embedding it into our most critical data workflow alongside other security technologies. In conclusion, homomorphic encryption isn't a product you can simply buy. It's a fundamental capability, a new paradigm for building trust in the digital world. It empowers us to treat data not as a liability to be locked down, but is as secret access that can be used broadly and collaboratively. Thank you all.